Now that you know how to clean your area, prepare for your sample, properly opening a sample package, as well as packaging and sealing a sample, we can finally begin learning about the theory and operation of microscopes to identify particles through the microscope. Title slide, please. Photon Moment 7, an introduction to microscopy, including a very brief history, justification for use, and background on microscopy. Episode 4 greatly expands on the limited information presented here on the above topics. When teaching forensic microscopy at a Tier 1 university, several students admitted to me several weeks after the first lab that when I told them they would be learning theory and operation of a stereolight microscope and a polarizing light microscope, with both microscopes sitting in front of each student, like you see here, they didn't know which microscope was a stereo microscope and which was the polarizing light microscope. But after just several weeks, the students were able to use the microscopes to separate mixtures and identify each component in a mixture by its optical properties. While the theory of light and optics can be applied to histological or cell-based microscopy, which are the types of microscopy that most people are familiar with, the kind of microscopy being presented in this YouTube channel is analytical microscopy. That is, the identification, using the microscope, of nearly everything in your environment. What other analytical technique can analyze such diverse materials as minerals, botanicals, diatoms, explosives, fibers, and even mixtures? Analytical microscopy is basically using any microscope and microscopical technique in the separation, characterization, identification, and interpretation of particles from a sample. In case you didn't know, the stereo microscope in these images is on the left, and the polarized light microscope is on the right. You'll hear me talking a lot about a particle, so I should define what a particle is. A particle is any solid or semi-solid object with mass of any morphology capable of being observed by a photon or light, electron, or other type of microscope or combination of instrument with a microscope. A particle or object can also typically be thought of as a concentrated microscopic substance, usually made of a single chemical, but may also consist of multiple compounds, all being capable of being viewed with a microscope. Each of the images you see here can be thought of as containing particles, objects, specimens, or a group representing a sample. The plant leaf and minerals image is an example of a multi-component particle, object, specimen, or sample consisting of various particles. While we're defining terms, I should define microscope. A microscope is a device containing a lens or combination of lenses using light or other kinds of radiation, resulting in a resolved, enlarged image of an object. The microscope can be something as simple as a hand lens, or as sophisticated as an electron microscope with various detectors. When society decides to take a closer look at something, they say to put it under a microscope, as these various headlines describe. When they need a scientific tool to represent science or to get really colorful pictures, they turn to the microscope. Even in scientific areas that have nothing to do with microscopy, such as chromatographic science or analytical toxicology, or just a journal that represents a general science perspective. A very brief history of the microscope. The history of the compound microscope, which is a microscope with an objective lens and an eyepiece or ocular lens, began over 400 years ago. Reportedly, a father and son, Hans and Zacharias Janssen, are credited with the development of the microscope, though there is some controversy about this. Learn more in episode 04, Introduction to Microscopy. The word microscope comes from the Greek word mikros, meaning small, and scopein, a Latinized Greek, meaning to look at, observe, or view. The word actually originated in 1624 specifically for Galileo so that he could better describe an instrument he called his little spectacle. Robert Hooke used both a single-lens magnifying microscope and one of the early compound microscopes. This is a drawing of one he actually used. Note the device he made to magnify the light from the flame, increasing the illumination onto the object he was observing. In 1665, Hooke produced the book Micrographia. And this is a drawing of one of many dozens of common objects that Hooke saw with his microscopes and published in Micrographia. Pretty amazing, isn't it? You can find a free, modernized language of Micrographia in PDF form on the internet. The highest magnifications attainable at the time were between 20 and 30 times. And then came Antony van Leeuwenhoek, just a few short years after Micrographia was published, who produced single-lens microscopes with magnifications almost 10 times that used by Hooke and others in England. Van Leeuwenhoek was able to see things that no one else had ever seen before or documented. See episode 4 and read Single Lens by Brian Ford or any of his many other publications on the subject to learn more. Over the centuries, many improvements to the microscope stand, optics, and understanding of light with its interaction with matter were developed. In particular, in the mid to late 1800s to early 1900s, great leaps transpired in understanding of lenses, aberrations in lenses, their corrections, as well as understanding of light. These are some of the references for this presentation. Be sure to click the subscribe button to help others find this content.